Hi everyone. So today I'll be taking you through installing some of the tools needed for TinyTapeOut IHP26. And first, you need to clone this repo, the OSIC tools. So you need to clone here. I already have this. And in here, I'll show you some of the modifications you can make. So the first thing I did was to specify the Docker platform. It's a Linux AMD64. This is an M1 Mac, so this is the ARM64 platform, but there might be some compatibility issues with some EDA tools. Here, Docker pull modification I just removed, putting this in the null terminal and instead of printing it out to the standard terminal. Another application you'll need is SOCAT, so you can do that by brew install SOCAT. That's needed. And once that's done, run the script. It will set your design directory to your home, EDA tools, designs, and it should spin up a container. So you might need to pause the video to let Docker pull down the image. Once the container is up and running, press S to start. That'll bring in next terminal, next window. And here we have nothing. So if this doesn't pop up, you want to make sure you have the settings set up in exports under security to allow connections from network clients. And after doing that, in your Mac terminal, type xhost plus localhost, and that adds the localhost to the control list, so you can create new client windows from the localhost. And going back here, we can check environment variables, PDK, root, that's correct. We should have the IHP26 this is 26a, and this is the PDK SG13G2. So we can create an example inverter to make sure everything compiles and the spice works. Let's get into this. Open Xchem. I'll open up this window. So we're going to be taking a test case for the logic not inverter. And I'm going to save this into our inverter. Design. Yeah. Okay. Then we open. Okay. Once that's done, the first thing we can do is to create the netlist. Clicking this button. We should have a netlist created. So verify that. You can look in here. Our schematic was saved, and we also have a simulation directory. Inside that, we have the spice netlist. And now we can simulate this terminal pop-up. Writes the results of the simulation to a binary raw file. And we can load that file into the plot. So here you can see the output here coming from the two drains of the NMOS and PMOS transistors. It goes from 1.8 volts all the way down to 0 volts. And we can also add the input to this graph by double-clicking, checking the signals in here for in, double-click, and we should see the in ramp from 0 all the way up to 1.8. And that's what we see here being programmed in as the PC ramp from 0 to 1.8 with the 0.01 increments. And once that's done, you can save this. You should have your spice and your raw for your simulation. That's all. Thank you.